Okay, so back to some more probability here in Unit 4. Regular geometry. Use an area model tree diagram, or refer to the table. We don't have a table with us. Let's use an area model for this one, since we've done a lot of tree models so far in homework. It says, the sum of the numbers of rolling 2 standard 6-sided dice. Okay, so I'm just going to create a little area model table here. So I'm going to have one roll of the dice going horizontally, another roll of the dice going vertically, so 1, 2, 3, 4, 5, 6, okay, there's that, and then 1, 2, 3, these lines are straight lines, but they're not all parallel, are they? Okay, we'll get the idea. Okay, so there's our area model grid. So in one direction we have the possibilities of the die 1, 2, 3, 4, 5, 6, and going the other direction we have 1, 2, 3, 4. Of course, I need to get in the way. Let's do it over here. 1, 2, 3, 4, 5, 6. So now we need the sums here, right? So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 1 is 7, 6 plus 2 is 8, 5 plus 2 is 7, 4 plus 2 is 6, 3 plus 2 is 5, 2 plus 2 is 4, and 2 plus 1 is 3. 3 plus 1 is 4, 3 plus 2 is 5, there's 6, there's 7, there's 8, there's 9, there's 10, 9, 8, 7, 6, 5, 6, 7, 8, 9, 10, 11, 6 plus 6 is 12, 11, 10, 9, 8, 7. Okay, so those are all the possibilities in terms of adding those two possible things together. Okay, so as you can see, there's only one possibility where you can get a sum of 2, snake guys, right? 1 and 1. There's only one possibility where you can get a 12. The rest of them have multiple instances. You know, it looks like 7, 6, and 8 are probably the most popular choices, or most probable choices. In a standard casino dice game, the roller wins on the first roll if he rolls a sum of 7 or 11. What is the probability of winning on the first roll? So first of all, there are 36 possibilities here, right? So that probability is going to be something out of 36. Now we just got to go through and mark all the ones that will add up to 7 or 11. So let's see, so there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 out of 36 chances. So 8/36 chance that it'll win on the first roll. Part B. The player loses on the first roll if he rolls a sum of 2, 3, or 12. What's the probability of losing? So we're going to add up all the ones that are 2, 3, or 12. So 1, 2, 3, 4. Okay. So 4 out of 36 chance that they would lose. Okay. The player rolls any other sum. He continues to roll the dice until the first sum he rolled comes up again, or until he rolls a 7, whichever happens sooner. What is the probability that the game continues after the first roll? So what we're looking is to see the probability that they roll something that is not a sum of 7, 11, 2, 3, or 12, right? because if they roll a 7 or 11, then boom, they win. Okay, it's done. If they roll a 2, 3, or 12, they lose. It's over. So we're looking for the probability that they roll something that would make the game continue, right, beyond the first roll. So we could go through and we could find all the instances where it would add up to everything except 7, 11, 2, 3, or 12. Or what we can do is, since we know this is 836 and this is 436, when we add those together, we get 1236. So this is the probability of it ending on the first roll. Either you win or you lose. So there's a 1236 or 1/3 chance that the game's going to end right there in the first roll. So that means if we subtract that to find the resultant probability, because we know it has to add up to 100%. So if we do 36 36 minus the 12 36, that's going to give us a 24 36 chance that the game would continue after the first roll, which would then put it down into, that looks like a 2/3 chance, or a 2/3 chance that the game would continue. Okay, so, obviously, this, it may seem like it doesn't work out to the casino's advantage, but it does. There's not really a high chance of losing on the first roll. There's not really a high chance of winning on the first roll, but the game's going to continue, and the people are going to obviously bet more money and put more value on it because they think they're winning and the game's continuing on. But then notice that after that, they then lose if you roll a 7 or you roll the first sum again. So then that probability of losing actually becomes larger and larger. The more people are putting money on there, and then so you're actually playing against the odds. So if you can win on the first roll, awesome. If not, your odds keep diminishing, getting smaller and smaller. Okay, if you have any questions about how those probabilities worked out or how we use the Airy model to find those, feel free to ask a question or comment. Otherwise, more than likely you're welcome to like, subscribe, or share our videos.